Hello students, welcome to Form 3 Computer Lessons. In this topic, we shall cover the following areas: description of a system, definition of an information system, purpose of an information system, and stages of system development.
Introduction. System development is the process of defining, designing, testing, and implementing a new software or program. System development is the creation of a system using a step-by-step procedure. Definition of a system. A system is a set of organized independent components that work together within a given boundary to achieve a common goal.
Figure 3 is an illustration showing the components of a system. Control. This involves monitoring and evaluating feedback to determine whether a system is moving towards the achievement of its goal. In order to monitor the performance of the system, some kind of feedback mechanism is required. A system with feedback and control components is called an adaptive system. Input. It involves capturing data to be processed. Input. It involves capturing data to be processed from the environment. For example, raw materials, data, and human efforts must be organized for processing. Processing. It involves conversion of the input into meaningful information. Processing. It involves conversion of the input into meaningful information in the view of the user. Examples are a manufacturing process, the human breathing process, or mathematical calculation. Output. It involves conveying the end result of processing to the user. For example, finished products and human services must be transmitted to their human users. Boundary and environment. Every system has defined boundary within which its components operate.
Types of systems. Systems fall into a number of categories. It is important to know the type of system you're dealing with. Open and closed systems, hard and soft systems. Additional types of systems: conceptual and physical systems, deterministic and probabilistic system. These open and closed systems. An open system is one that interacts with the environment. A business organization is an open system because it exchanges material and information with the environment. It does not provide for its own control or modification, thus it does not supervise itself. It needs to be supervised by people, for example, the school system.
Hard and soft systems. Systems can also be classified as hard or soft systems. Soft systems have got no clear defined goals and objectives, hence their performance cannot be precisely measured. For example, sales tracking system, where sales performance depend on human factors such as the prevailing conditions, which include availability of money, customers, products, and human preferences. Hard systems are systems whose goals and objectives are clearly defined and the outcomes from the processes are predictable. For example, in a stock control system, it is possible to know exactly the stock level, the reorder, and the profits can be accurately predicted if all the stock is sold. Conceptual or physical systems. Systems can be conceptual, abstract, or physical. An abstract system is an orderly arrangement of independent ideas. Conceptual systems are concerned with theoretical structures which may or may not have counterparts in the real world. Thus, conceptual systems are systems of explanation or ideas or constructs. For example, data flow diagrams in system development. Physical systems are concrete operational systems made up of people, material, machines, energy, and other physical things. Physical systems can display activity or behavior. Examples include business organizations and computer systems. The deterministic and probabilistic systems. Systems can also be deterministic or probabilistic. A deterministic system operates in a predictable manner. If one knows the state of a system at a given point of time or can predict the next state without error, then it is a deterministic system. If one cannot predict the next state without an error, then it is a probabilistic system. For example, in computer systems, the outputs are deterministic, while weather forecasting systems and inventory systems are probabilistic.
Purpose of system development. There must be a reason for the development of a system. This may come either from the management, users, customers, government, or any stakeholders of the organization. Information system. Any information system can be defined as a system that accepts data resources as input and processes them into information products as output. Components of an information system. End users. End users are people who enter input into the system and use the output from the system. Examples of end users include students, accountants, teachers, salespersons, and engineers. Information system specialists. These are people who develop and operate information systems. They include systems analysts, programmers, and computer operators. Hardware. Hardware refers to all physical devices and materials used in information processing. Software. The term software is generally used to refer to programs which direct and control computer hardware as well as procedures. Data. Data can be defined as raw facts and figures that have less meaning to the user. For example, in a school system's data that may be stored about a student include age, name, admission number, class, stream, date of birth, and date of admission.
Information systems can be classified in many ways, such as on the basis of the mode of processing, the system objectives, the type of functions the system supports. Classification by mode of processing. One form of processing is batch processing systems. This is a type of information system where transactions are collected as they occur but processed periodically as a batch. For example, once a week, once a fortnight, or once a month. An example of a batch system is payroll system, which is processed once a month. Online systems. This is a type of information system where the transactions are captured by the online data entry devices. Real-time systems. This is a type of information system where data capture as well as their processing is carried out at the same time as the transaction is taking place. The records files are updated instantly. Classification by system objectives. Transaction Processing System, TPS. These are information systems that capture and process data about business transactions. Their objective is to process transactions in order to update records and generate reports. Examples include payroll systems, electricity bill systems, stock control systems, and airline reservation systems. Decision Support Systems, DSS. These are information systems that provide the users with decision-oriented information whenever a decision-making situation arises. Their objective is to support managerial decisions and is usually based on a model of decision-making domain. Examples include spreadsheet programs such as Microsoft Excel and Lotus 1, 2, 3. Expert Systems, ES. These are programmed decision-making information systems that capture and reproduce the knowledge and expertise of an expert problem solver or decision maker and then simulate the thinking or actions of that expert. The Management Information System, MIS. These are information systems that condense and convert transaction processing systems data into information for monitoring performance and managing organizations. Classification based on the functions the system supports. Finance and accounting systems. These are systems that maintain records concerning the flow of funds in the firm and produce financial statements such as income statements, billings, and balance sheets. Information systems play major roles in organizations which lead to improvement in efficiency and effectiveness of business processes.
System development methods. These refer to the different ways that can be used to develop a system. Some of these methods include waterfall method, prototyping method, evolutionary method, and system development life cycle (SDLC). For this lesson, we will adapt the system development life cycle (SDLC) method. System Development Life Cycle (SDLC). It consists of the following stages: problem recognition and definition, information gathering, requirement specifications, system design, system construction or coding, system implementation and testing, and system review and maintenance.
SDLC recognizes the existence of a life cycle of a system from the conception of an idea to the decay of the system. There are 8 stages of system development life cycle, SDLC. These include problem identification, feasibility study, system requirements analysis, system design, system coding, system testing, system implementation, and system evaluation and maintenance.
Problem recognition and definition. In problem recognition stage, a problem is identified and its magnitude expressed. It is important to be very keen in this stage as each detail affects the next stages. Feasibility study is a study carried out to determine the possibility of either improving the existing system or developing a completely new system. This study helps to obtain an overview of the problem and an assessment of whether feasible solutions exist. Methods of carrying out feasibility study. The following are methods used to carry out a feasibility study. Technical Operational feasibility. This is a study done to determine whether the users would be able to operate the new system or they will require training. The new system should fit well into the existing operational structure of the organization. Schedule feasibility. This is a study carried out to determine the time duration required to design and implement the system. Depending on the complexity of the project, it may take a few months for a simple system or even years for more complex systems to be completed. Legal feasibility. This is a study carried out to check whether the new system is in line with the current laws. The new system is evaluated to ensure it complies with the company objectives and the government policy. Information gathering. It refers to different ways used to collect data. Methods of data collection refer to the ideal strategy or tool or approach to use to collect or gather data. Some of the methods that can be used include questionnaires, interviews, observation, and documentation review. Review of the current documents. This is the studying of the available documents that portrays the nature of the existing system. These are documents such as reports, forms, manuals, business plans, policy statements, and organizational charts. Interviews. An interview is whereby the interviewer probes the user of the current system in order to get information about the current system. They are face-to-face encounters.
Questionnaires. A questionnaire is a document containing a number of questions set by the systems analyst used to gather information from users about the current system. Observation. This is a fact-finding method where the systems analyst either participates in or watches a person perform activities to learn about the system.
Requirement specifications. In this stage, the system analyst identifies what is needed from and for the new system in order for it to achieve its defined objectives. System design. This is the stage where the analyst uses a suitable algorithm to depict a system's logic. System construction or coding. This refers to the act of building an information system based on the design specifications. Testing. This is the running of the whole system against test data to evaluate the compliance of the system requirements with the sources, which include hardware devices, computer programs, and information processing procedures. Stages of testing. Unit testing. This is the testing of individual parts of the system. If the system is written as a collaborative effort by many programmers, each part of the system is tested separately as a unit or program module. System testing. This is where program modules are linked together and test data is used to see if the parts work together. At this point, actual data organization may be used to test the system. User acceptance testing. This is done to ensure the system meets the user's needs. It is usually carried out by the user or on behalf of the users.
Types of test data. Live data. This is data that is currently being used by the organization. Program data. This is data used by the programmer when developing the program. Historical data. This is data which was previously used by the organization and which is no longer valid. Suite data. This is data for the whole system to ensure that the suite works correctly and that various program links work as required. It's important when testing to produce tentative copies of displays, reports, and other outputs. This should be reviewed by end users of the proposed system for possible design errors.
Implementation. It is the installation and configuration of the new system so that it can be used. Activities performed during this stage include installation of hardware and software, which include file conversion and training users. Implementation strategies. There are three major ways of implementing a new system, namely straight or direct changeover. This is a changeover strategy where the old system is abandoned and the new system is put to use immediately. Parallel changeover. This is a changeover strategy where the old and the new system are used concurrently. When the users feel comfortable with the new system, the old system is phased out. Phase changeover. This is where each part or module of the new system is implemented in stages. Pilot changeover. This is where the new system is implemented in only one department or branch of the organization. If successful, it is implemented in all the other departments or branches. System review and maintenance. System review involves assessing the strengths and weaknesses of information systems in order to improve their effectiveness. Documentation. It is the writing of detailed instructions at every stage of the system development. These instructions can be used to guide the programmers, users, and for future maintenance of the system. We have different types of documentations: user-oriented documentation, operator-oriented documentation, and programmer-oriented documentation. Good system documentation usually consists of the following: reports on fact-finding or information gathering, system flowchart, table or file structure or description, sample data, output reports, and user manual.